Well, good day, everyone. Welcome to another presentation during this fall hot topic. I see that there's quite a lot of participants. We certainly do appreciate that participation. And even though I'm by myself today, I'm sure between the girls and myself, we'll be able to answer your questions. But just in case, I promise anything goes unanswered, we will definitely get back with you. So today's presentation is really all about controlling moisture in concrete products, but just a little blurb, a little bit about me first. My name is Lisa Pelham. I work for a company, Oldcastle APG. Oldcastle is a very large building products company. We're worldwide. We're based in Dublin, Ireland. In fact, my parent company, CRH, Cement Roadstone Holdings. And in North America, we actually have three divisions. So we have my division, which is the Architectural Products Group. And then we also have an infrastructure. It's precast, but nothing decorative, very much for site utilization. And then we also have a materials division, which is our aggregates and sands and cements. So just a quick glance at in my group, what we actually either produce or distribute. Very big into the hardscapes. Many of you may know the Belgard name. So with that, that's concrete, interlocking concrete pavers. It's also our segmented retaining walls. Our Technoseal products fall under there, as well as our West Tile and Permacon. Then we also have, moving on, we have packaged products. We have pre-blended grouts and mortars and stuccos. So if you do visit home centers, we usually have a branding of Satcrete for the home center business, and our Amerimix is our branding for our pro business. So I'm not sure if any of you are familiar with pre-blended products, but I will tell you they have come such a long way in the last 10, 15 years. I highly encourage all of you to look into that. It's very, very consistent materials. Then our masonry side is we try to brand it with our echelon. So echelon simply means it's just a vertical application. So we have things like ground face block, regular architectural block, like split face block. We also are a huge distributor of clay products, of stone products, both natural and manufactured, and a lot of different thin products too. The thin products, if anything, has really blossomed over the last few years. We have a lawn and garden section. We also have composite decking and fencing and railings. So I like to show this side simply because it's a very large company. We have almost 200 locations, over 6,000 employees, but we're really one group. So as a designer, an architect, or an engineer, if you're inside the state of Florida, great. If you are inside and you're designing outside of the state, we have multiple locations that have very similar products. And as well as if you're outside of the state of Florida and designing within the state, again, we have such similar products. So I certainly just like to encourage all of you that there is quite a lot to offer. So now moving on to Florida Masonry. I always like to do a little blurb about Florida Masonry. The Florida Masonry, which is our Masonry Association, is a non-profit trade organization that really represents our industry. It's really mostly contractors in the state of Florida, but with this, we really have a few key initiatives. We provide education, we provide resources to the masonry industry, and also we educate them on the benefits of building with masonry. And that's not only educating design professionals, but also apprentices. We're very, very into our apprenticeship programs. So in a nutshell, we offer the professional education to architects, engineers, our apprenticeship training, and then we also have technical assistance through our engineering help desk and library. Now, we started this initiative back in the day. Well, we've been around forever, but we started able to fund better about 10, 15 years ago. We actually had a voluntary checkoff program. So for every penny or for every gray block that's produced, a penny goes into the pot, and anybody could buy for this, but it does have to be to do with training, with apprenticeship, and also that end user. And that end user, lastly, our Block Strong initiative. This is something that blockstrong.com, I would encourage all of you to just take a look at this website. It really gives a snapshot of the benefits of building with concrete block. And many times, as a professional, you're very familiar with different products. But as a homeowner, homeowners are not always sure of what they're getting. So this is a great website. All right, so today's presentation, Controlling Moisture in Masonry, my due diligence slide. We, Architects Oldcastle APG, is a registered provider with the AIA Continuing Education System, and I promise to make sure that we're on point in regards to this presentation. So our learning objectives today, we'll discuss flashing and other proper masonry installation strategies to really manage moisture in a masonry wall. I want to explain the advantages of complete masonry systems. It really helps mitigate water penetration and provides a very good backup for any kind of moisture management. I'm going to describe the water repellent admixtures that we use in concrete block and mortar that really help control those moisture issues, and then show how to specify a masonry solution that really delivers a superior moisture control as well as an environmentally sound structure. So why masonry? Well, concrete masonry products, they're available in an array of colors, of textures. We have different profiles. Really, it's up to the designer for those options. We have so many different things in the marketplace now. If you think about concrete, the inherent strength and durability, it really makes it a suitable product for the long haul. With the advanced block and mortar admixtures and a belt and suspender approach, we really can create a seamless moisture prevention solution. And just simply, the architectural concrete masonry, they just speak the balance of both strength and beauty. So a couple projects, and most of these projects that I'm highlighting are in Florida. I'm based in Florida, but this one is really a unique project. It's a church, it's a Greek Orthodox church, and it's incorporating clay brick and architectural block. And these are two items, block and brick. They've been around for years and they mix well together as long as you're designing with that differential movement in mind. They really do mix very well. I will say this one's more of the more unusual ones where they actually encapsulated some of the block with the brick. So very unique. Another project, a Jewish community center. This one is a veneer. It's a polished unit and it's 16-inch pieces in length, 8 inches high and 4 inches high. But the way that they had 4 different colors that they mixed and matched to really elongate some of those profiles. Another beautiful project is in University of Florida. It's actually the Institute of Black and Hispanic Latin Culture. This is something where it's another polished architectural block. You do see brick that is set proud many times. Rarely do I see this on a block project. So this is certainly one to showcase. Absolutely beautiful. This particular project's the Southside Senior Center in Jacksonville, Florida. Very hard to tell from this snapshot, but this is actually a block that as an aggregate, it's got seashell. So it's ground seashell that's in this block, and it really is a stunning project, especially for that coastal feel. And not all products, obviously, are just for buildings. Just having a landscape design in mind can really just make everything come into place, really tie in your interiors with your exteriors. Sorry about that. This one is an old tried and true. I like to show it simply because It works. It's a 16 by 16 veneer. It is a post office in Pennsylvania. It initially was specified for a granite and it just kept coming in so over budget. So they went back to the drawing board, and this is actually a polished and sealed unit. There's several different companies that produce these today, and it just is a very beautiful, beautiful project. All right, so learning objective one, discuss flashing and other masonry installation strategies to really manage that moisture in a wall. So we're going to start with some basics. What is a concrete masonry unit? So a concrete block is comprised of sand, cement, and rock, or an aggregate. Then depending on the type of product that you're actually producing, color pigments can be introduced, as well as various admixtures, say an integral water repellent, and many times recycled material. So block is something that is a dry cast manufacturing process. So the dry cast, it's been around for years and years. If you think about a cake mix, you're mixing the cake above your head. It's got the dry mix of aggregate cement, then a little bit of water is added in, less than 6%. And then if you're going to have colors, those or some of the other admixtures are then added in. And it's all mixed together. It then comes down into a chute, and it gets put into a mold box. It then gets vibrated at a very high rate of speed. This is actually how you achieve compressive strengths. That mold box lifts off, and that product goes down the conveyor belt to go into the kiln. Now that product, depending on the product you're producing, for the most part, it's already a product. So if you're producing a smooth block, or maybe you're going to grind the block later, face or faces, you're going to have that 8 by 8 by 16, if that's the size that you're producing, already formed. Now, as soon as that mold box releases and that product goes on its way, if I was to take my hand, I could smush it, but within 10-15 minutes, it is hard, 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 and then it goes on to the kiln. So if it's like an architectural split face block, it's going to be a double product, because after it goes to the kiln, it comes back around and then it gets split. So the fact that you can just do so many molds an hour, you can produce about 2,000 8-inch equivalents every hour. You can imagine how many block you can produce in a day. I should say a shift, a day, and in a week. So moisture mitigation is our enemy, and we're always trying to make sure that we combat that. So how moisture actually enters a structure, it could be a hairline crack. Maybe it's a detail in the parapet. Maybe it was the installation. Maybe a door and window, a structural break in the wall. There's vapor. Of course, there's always workmanship or poor workmanship, and lack of drainage. You want to always design with, you're thinking moisture might get in. How is it going to get back out? So driving rain, a capillary action, water vapor, and groundwater are all sources of water in a masonry wall. So masonry units are very absorptive, very, very porous. You have to do something with it. So that would be either a stucco or a paint, or an integral water repellent, colored or an integral water repellent, something. Something has to happen for you to make sure that you are combating moisture just pouring in from the face. So moisture inside the masonry system, it could cause breakdown of anchors, of ties. It rusts things out, other reinforcing material. This case is showing this is moisture that is evaporating from the product, and it leaves behind kind of a white scum, better known as efflorescence, something that can absolutely be cleaned. But this is just the process of moisture and moisture drying out. Unfortunately, there's also other moisture sources. If there's a scupper or a gutter detail, it could just kind of wreak havoc on a particular wall section as well if it's not drained properly. So designing walls with moisture penetration in mind is a must. You design walls with multiple lines of defense. The whole intent is to protect the occupants from any type of moisture penetration into your structural component. And really, sometimes you might need to actually have a belt and suspenders approach to this. So the perfect wall, this was actually an article that was written by Joe Stebrick, Silent L, probably like 2009. I just now am looking at my notes, so I knew it was probably a good 15 years ago. Honestly though, this is a perfect wall. It's a cavity wall system. And so it not only you allows the veneer that you would like, but it's protecting the occupants with your backup structure. So you have whatever cladding you might have. You have this rain control barrier, which is actually your cavity. You're going to have a thermal control layer. So you're going to have some sort of weather resistant barrier. You can also, depending on what part of the United States you're in, you might want to insulate in the cavity. When it's the warmer climates, that's what we prefer to do if at all possible. And then you actually have your structure. So the rain screen principle is really when we talk about that in a cavity wall system, it's really the gravity. What happens for the rain screen principle is moisture hits the veneer. Now, many times it is not coming through the face of the veneer, but it is actually coming through little pinhole cracks in the mortar. The intent is for it to slide down, slide, slide, slide. It actually hits the flashing and then it escapes from the weep. So this same principle can also be used with single white as well. So you have that same mindset. So to proper manage moisture mitigation, there's multiple steps to take. Flashing, counter flashing, weeps, vents, sealants, water repellents, perhaps post-applied surface treatments. There's all kinds of measures. And there's really an order of importance and maybe an order to installation. But once you've got these in place, you're good to go. Always just the redundant use of the materials. You always want to have a surface protection, internal protection, and then the draining and the drying, which is more the flashing and the weeps. So in a veneer wall, the cavity wall lines of defense, you have your veneer, as I showed on that perfect wall slide. You have a true cavity. You're going to have perhaps some insulation, perhaps not, depending on where you are. Here, we're going to have definite flashing and weeps. This is very important. And then, of course, you have your backup wall. Now, in single white, and there's multiple ways to build. This one is just one example of having two 4-inch block at the bottom, but many times there's a single 8-inch block if your wall is an 8-inch block, or a 12-inch block for the single white. Also having that integral water repellent. If this is an architectural exposed unit, you're going to have some drainable cores. Obviously, you're going to have some because it's going to be structural. So some of those are going to be grouted as well, depending on what the specifications call for. If it's fully grouted, partially grouted, whatever the case may be. Definite flashing and weeps. You also have that protection on the interior face shell. And then I always recommend having a post-applied water repellent after the construction of this wall. They make a lot of different products too that are on the market. For example, if you do have a single white for flashing and weeps, there's a product called Block Flash, and it's actually a pan with a weep that is integrated into it that you would use. Excuse me. So there is really, many of these products are no-brainer kind of products. You know, I apologize because I think the last time I did the presentation, I had a cold and I think I'm picking up another one, so I may have to stop and cough. My apologies. So the thin veneer lines of defense, here we're going to have, of course, you have, oops, excuse me, you're going to have your thin product, whatever that may be. It might be a thin stone, it might be a thin brick. It might even be a thin CMU. You'll definitely have some sort of setting bed, and depending on where you are in the part of the country, thin veneers have really changed this last code cycle. In Florida, we still use our previous code, but we're starting to integrate the new code. So moving forward, instead of just, for example, the setting bed is a type S, it will now be a polymer fortified mortar. So we'll get into that in a little bit more, but definitely having a drainage mat, your galvanized metal lath, and then some sort of backup. And then, of course, your structural element. So flashing, so important. It's really the unseen, but extremely important. When during the construction cycle, it's important that you do see this flashing. Clearly, if you're going to have an inspection, they need to know that the flashing is put in place properly, but it's also for other trades that are coming in after. Flashing is something that can be cut flush later, but it's super important to understand where that flashing is. So the whole goal behind flashing is to really reduce the water penetration and to divert that water back out. So some of the attributes of flashing would be if it's durable, the imperviousness, the corrosion resistance, depending on what other materials are around that flashing, making it user-friendly. Some flashings are very hard, some of them are more pliable, just depending on what's spec'd, what's comfortable, what the project should have. Some of the movement control adhesives also that are out there, flashing should never cause any kind of discoloration of the masonry unit, and clearly it needs to be the expected lifetime of the flashing is the lifetime of the building. So some of the various flashing types, we have metals, we have copper composites, there's loose or PVC kind of flashing. There's also self-adhering membranes. So we always want to make sure that you're choosing to last the life of the building. So flashing and a quality moisture control system will really help the moisture that's trapped inside to get it back out. So the reason of the flashing, you want to make sure that you put it anywhere where there might be an obstruction to the downward flow of that moisture within the wall, or perhaps anywhere that there are offsets or horizontal surfaces in the exterior veneer. So, for example, the base of foundation. Now, this is above grade. You definitely don't want to put it at grade. This is above grade. If you have openings, doors, or windows, any kind of lintels, if you have bond beams, parapets, intermediate roofs. So here's a great example of required flashing locations. So here we have a parapet wall, an example of a masonry coping that you have your flashing under it. So it's just important to make sure that that flashing is known. It's important. It's also important to have drip edges on many of the wall caps or copings. A drip edge is something that honestly, it could be cut at the factory typically quite easily. And it's really just a very, maybe an eighth of a cut that would allow when moisture does come down that it hits that drip edge and drips down. So it's not folding back and hitting your project. Other required flashing locations are shelf angles. Shelf angles is something that's paramount when you have brick construction. Brick is a product that continues to grow its lifetime. So as it comes out of the kiln and it is actually fired, where a concrete masonry product is humidity cured, even in winter up north, unless they have to get something out, they may shoot it 500, 700 degrees, but typically all block, they like to have it cured by humidity if at all possible. But anyway, so shelf angles, Shelf angles is something that's very important in the brick industry. Because your brick is growing, you're actually needing to accommodate for that growth. So I have a couple examples. Here we have your shelf angle. Now, you don't really see it here, but a shelf angle typically has a very thick mortar joint. It's about twice as thick as the typical 3/8 of an inch. So here's an example. You have your flashing that's right over this shelf angle. But I mentioned about that mortar joint. It might be something that your client may not pay attention to. Many laymen may not pay attention to. But once I point it out and you see it in a building, you'll probably always pay attention to it. Well, nowadays they make a lipped brick product. So this lipped brick actually allows for continuity of the mortar joints all the way up. So here we have our flashing actually above the shelf angle. And in my last illustration, I'm showing one on the shelf angle. And I will say this predominantly is the most used detail that I've seen out there. So other required flashing locations, I mentioned the heads of masonry openings, the base, the sill pieces, if it's a window opening. So just important to be able to see. Here we have a flashing above the doorway. And then here we have a window detail. So flashing above the window. And here we have actually the steel lentil angle iron, which is a little different than your shelf angle because it's not directly attached to the substrate in this instance. But you see we have this through wall flashing, and then you have your weeps. So that flashing directs that water out, and the weeps allow it to go out and evaporate. And then you also have a sill detail. Now, you're going to have flashing. In this case, the flashing is below the sill detail. And if you do use a brick for a sill detail, 2 comments on this slide. One, this should be solid. You should not have a cord brick as a sill detail. So many times when you do specify a project, your products, even though ASTM C216 calls out that it's a solid facing brick, it's actually 75% solid or more. Excuse me. They do produce totally solid units also. So not only should this be a solid unit, but always make sure that you have a 15-degree angle or about 3/4 of an inch. We have sill flashing again, just another snapshot of that. And then other required flashing locations would be the base of the veneer wall. So this is why it's so important to see it. So when they do an inspection, or if the architect, it's time to come out and see where they're at in the project, you want to be able to see, not to mention the project superintendent, but you want to be able to see where that flashing is. So here is an example. And again, we're talking about the course above grade. Well, in this instance, they put the flashing above the outside grade, but this is grade. This is our slab. This is our structure. So what happens is, unfortunately, you could have another trade come along, bam, they've just covered up this flashing, and this course, this does no good. But had it been up here or even up here, it would have done what it needs to do. So again, very, very important when installing, when looking and checking, inspecting, that you see that flashing. And then another example of base wall flashing. I'm just going to take a quick second and see what kind of questions I have. Okay, my question, I'm going to read them out loud since I'm alone today, but what does Oldcastle recommend for reading to train masonry installers to facilitate the best practices in the industry? Well, I will say that There is core curriculum. There's also, we actually have a program in Florida that, and I believe the Carolinas has a similar setup, and I apologize, I'm not sure about the other states. It's actually a 3-year program, and the program has actual books, so you have classroom time and you have on-the-job training. And that classroom time is classroom time as well as training in the class, but outside, so you're actually on a wall. And then you have on-the-job training. And I believe it's similar to 16 hours of in-class training, which includes hands-on too, and then in the field training is 2,000 hours, and that's every year. So there is a definite curriculum that goes with training the apprentices. So another question was, and I hope that answered enough. It's probably a little bit vague, but there is an actual set program. So we do not use brick veneer in this part of Florida, but the typical is CMU and stucco. What is the flashing recommendation at windows for this application? So it would be similar if you have stucco, that you have flashing that goes under the block, because the block is what you're stuccoing. And then when you're on your window, also, I will tell you, NCMA, and they now go by CRHA, but you still look it up, ncma.org. They have a plethora of information. They have a technical library. So when you click on the site and you go to Site Solutions, you can click on Technical Notes. They have notes, they have details, and there's a tremendous amount of information that shows actually how to flash for all applications, not just brick and block, even steel, anything. So great website for sure. Okay, so I think I got those. All right, so now when you talk about the flashing, it's not only, I lost my mouse, there we go. It's not only directing that water straight on, but if you think about a window detail or even a door detail, you need to protect the other side of the doors or the windows. So the end dams are just like what they said. They actually allow that water to be directed. So if this is the end of the window or the door, this is where the end dam would go, and then your regular flashing. So it's very important because we're directing that moisture. So we're not only directing it as just a straight profile, but we're directing the corners as well. And speaking of corners, this is just a quick little highlight of the best way to actually lap and overlap, so you are protecting the interior of the block. The whole intent, single wipe and double wipe, is to protect that structural unit. So weep holes is part of the flashing system. Now, weep holes are something, they make various products on the market today, and TMS demands that at least every 33 inches on center. But the BIA, which is the Brick Institute, they actually recommend a little bit less than 33 inches. And why not? You're protecting that interior, that structure. Why not have a few more? So their suggestion is, if it's an actual weep hole, it's 24 inches on center. And if it's a wick, it's actually 16 inches on center. So I've got a picture that will show you all of these, but their main focus is an open head joint. Now for block work, I typically see a weep or a wick. I have once in a while seen an open head joint, but for brick work, typically that's what I see, is an open head joint. So here's an example of a rope wick. This is an example of a weep tube. And here is an open head joint. Now, they do make many screens that you can actually put in that open head joint. I mean, yes, there's a chance that there could be a critter or two that could actually come in and want to be in that cavity. But again, Block products are not a source for mold or anything like that, so typically they're not gonna just set in there, but again, they make plenty of different colors of screens nowadays as well. And I mentioned about the block flash earlier. Well, this is another product, a mortar net, which also helps keep your cavity clean. Because the idea, and I know I've got a couple pictures as we move on, the whole idea is to be able to allow that moisture to hit the flashing and escape, is to have a clean airspace. Now, granted, you're going to have some mortar splattings, but I have seen clean air spaces and I've seen junked up air spaces. So it's definitely a little bit more finesse. And lastly, this is just what the black flash, I mean, what the screen actually looks like once it's in the wall. Let me just do a quick little question and answer. So, okay, repeat the new NCMA name and website, nmca.org. You can still get to that website from that nomenclature, ncma.org. Uh, by far, this is one of the most used websites that I've used my entire career. And in it, when you go, if you go to Site Solutions and then hit Technical Notes or Details, that's where you're going to find there's going to be an index. There's 19 chapters, and it talks anywhere from flashing to how to build my spec to crack control. They have a manufactured stone veneer section. They actually have a retaining wall section. They talk about veneer construction. They talk about single wide construction. It's just, it's excellent. So another question was, I've seen on residential or multi where they transition from block at the base to perhaps framing. They don't seem to know how to flash that transition properly to account for movement and to allow the decorative cementatious finish to contract and expand. I usually see them do some sort of decorative banding. Any practical solutions for those situations? Honestly, you're still introducing a concrete product next to, say, it's going to be framed above. But I do recommend a transitional piece if at all possible, that can be flashed at that transitional piece. If nothing else, and the transitional piece to me might have a little bit of a slope, kind of like a sill, does not have to be overly dramatic, or it can, depending on your project, but it almost act as a ledge for the next components of that project to be set above. Okay, another question I have is, can you talk about penetrations through the flashing where where the continuous structure is needed, like continuous steel rebar? So where you have your continuous steel rebar, you're going to have vertical, maybe it's every 16-inch on center, let's just say. Where those cells have rebar, they're going to be grouted. So you don't have to worry about flashing where the rebar falls. Now, if you have horizontal rebar, like you're tying into your lentil, when you're actually tying it in, those are also going to be poured. So you might want to go up a couple courses or down a couple courses, depending on what type of opening or where you need to have some actual flashing, because wherever you're going to have grout, you should not have any moisture penetration in or out. Another question was, do you have a detail that might show a recommended flashing configuration when applying to thin brick to a mortar base? There is. I'm probably going to have to get back to you, but we do have a few details. I don't think it's in this presentation, but I am jotting down your name so I can hopefully find you and send something to you. And it's NCMA, National Concrete Masonry Association, NCMA. So how do you handle a structural bond beam with no steel? Well, I am assuming if it's a structural bond beam, it's either going to be poured or it's a precast lentil. So I'm not quite sure if I understand that question. You may have to ask something else. And then in Florida installations, a spray foam insulation is commonly used in the cavity. Yes and no. Yes, we still see spray foam applications. I do not see that as much though, but we still do, but it's really kind of a belt and suspenders. Oh, you know what? My image isn't frozen. I'm just answering questions at the moment. So, and honestly, having insulation within the cavity does not give us any issues with installation. I know having a two-man team would be so much better, and my apologies to everyone, but thank you. I appreciate your patience anyways. All right. So, and again, if I skipped over a question, I just missed it, I promise we'll get back to them, even if it's through an email later on. So, learning objective 2 is to explain the advantages of a complete masonry system. And what I want to do is just explain a couple of products that are on the marketplace today. And I'm kind of just going to breeze through this, but I want you to know that most every company has a kind of performance kind of a product that goes a little bit above and beyond. So I wanted to show you two that are in the marketplace today that I'm a little more familiar with. It's more of a system approach, and it really does give great moisture mitigations as well as some of the other components that you're always looking for. So one of the systems and is that is a insulated concrete masonry system. So basically in this application, you have an 8-inch block, you have 3 inches of a polystyrene foam, and then you have a veneer. And that veneer could be an architectural block, it could be brick, it could be stone. And what happens is this application actually has a couple things going on for it. It has these drainage planes that are in there, so it allows the moisture to percolate through. It's got these things called eyes up, and the reason for this particular wall system is it's got these, you can see them right here, but in the actual product, they're embedded within. It's these two stainless steel clips. So first of all, if there is a fire, polystyrene doesn't necessarily burn, but it will melt. Now, I'm talking if this is a horrible fire, because clearly this is on the exterior part of the wall. But if there is a fire and this does melt, these stainless steel clips are there to engage and lock in this veneer. So this is one system. This is not falling off. So if the need be that patrons need to get out or first responders need to get in, they're safe. A system such as this, just like this, has an R value of 16.2, like the steady state 75 degrees, but it's got an excellent R value. Now, there's components that make up this system because of the fact you have to lay it eyes up because of those stainless steel clips. You're going to have right and left corners. You're going to have jambs. You're going to have just pieces. You might have half block. This is a gasket that actually goes on the polystyrene foam between courses. So it actually falls under continuous insulation. So it's really just a great system. This is, you're going to actually, when the mason actually lays it, they're going to put mortar, which they call butter. You're going to butter this face, you're going to butter the back, and you're going to butter the front. And this, there's a tool right here that actually just helps keep everything neat. So as you move down the wall, you will have three tops, if you may, that are going to have moisture applied to it. You're going to insulate it similar. You already have such a high R value that it depends where you are, what additional insulation you may or may not need. Definitely, it's a structural unit. So depending on what your rebar positioning is, you're going to have rebar and grout, but it's just really a very good system. It's a top of the line system. Another system, and this system is actually a foam panel system. They do make a lot of metal panel systems. They're great on R values. This R value has a 15 steady state, but it's also something that having a panel, you can have someone that's not necessarily a masonry contractor actually do the work for you. This is a great system if you need to update a wall system as well. It can be new construction, but it can also be an older system. So again, there's drainage planes and they're actually on both sides of the system. And excuse me, the R value is a 9.1, not 15. It's a 9.1. But basically, you're going to hang the foam and the product is actually friction fitted. And then you'll point with mortar afterwards. So here's just a quick blurb of how it goes up. And again, one of the reasons, the average masonry contractor is about 50 years old. It's been that same about the average age for as long as I've been giving presentations. And while we do have new people coming up through the ranks, you still have a lot of people that have been in business for quite a long time. So it's just sometimes we need to have a system that we can open up to perhaps a stucco contractor or something along those lines. So again, it's just the complete masonry systems. There's a time and a place for both of them, but I did want to give you an example of some of the other products that are on the market today. So learning objective number 3, let me just peek to make sure on my questions. Vertical control expansion joints and where should they occur? Okay, so the a control joint is used for block and an expansion joint is used for brick. And that's because brick continues to grow, expand, and then contract, expand and contract. Where in a block continues to shrink. So that's why you need control joints. And I don't think this presentation has that, but basically control joints are also found on NCMA, but it's basically every 25 feet if you have a long wall, maybe 4 inches from the corners, if you have intersecting wall, or if you have different wall heights. So there's definitely areas for where those control joints or expansion joints should go as well. So in learning objective 3, just describing some of the water repellent admixtures, there's different ones that are on the market, but the most prominent and really the best used one is the liquid that's used in the manufacture of the CMU. Now, a water repellent is not used for a brick, but it is used for a concrete product. But you can't have a waterproofer. You have to have a water repellent because the whole idea is you need to have some sort of bond between your mortar and your block. Even with the brick, it's not completely water resistant because you need that bond in order to put the products together. So integral water repellents, when they're integral, they last the lifetime of the unit. Now, if it's a post-applied water repellent, it does not last the lifetime. It has to be maintained. Most of the products nowadays have a 10-year warranty. There are a few products, though, that have less. If you go for a higher sheen, you're going to need to apply more regularly. If you go for a lower sheen, you're going to have much longer lasting time. But the integral water repellent lasts the lifetime of that unit. So again, there's been several different kinds of water repellents throughout the day, but we have found that the polymetric admixtures are absolutely superior. And some of it because of the better bond between the units and the mortar, lower air content in this, the finished appearance of the block. It does not change the color of the block. I can remember way long time ago when water repellents were first coming out, and you can tell how long ago that was. But I had a few firms that did not like to design with it. Now, they did design with a cavity wall system more times than not, but they just didn't really care for the admixture. But I'm telling you, it does not change the color whatsoever. It is something that we believe in so much that if it's a integrally colored unit, we absolutely would put it in. It also really helps with effervescence. So on a job, you're not going to know if it has an integral water repellent or not unless you splash some water on it. As you can see, the block on the left, it pools. It has an absolute water repellent. It's not just sucking it in. Where the block on the right, it just, I mentioned earlier, block is very, very porous. So there are tests that go out with submittal packages, and the rain or the wind driven test E514, and I think it's a driving rain of 95 miles per hour, but you can clearly see products that have it and products that do not. And it's important that you not only specify it, because there are companies that come all over, and you want to make sure everybody is bidding apples to apples and you are getting what your design intent is going to be in the field as well. But you need to specify the integral water repellent in the mortar as well. And I did mention earlier about pre-blended mortars, and there's multiple companies that make pre-blended mortars. They have come such a long ways that you can actually get a bag or bulk, and it will have the cement, the sand, it'll have the color, and an integral water repellent in the mix. And you can actually detect that when it's in the mixes of the pre-blended mortar. So it's just something I just can't stress enough. So again, the integral water repellents were designed to address the problems that are common with job site applied repellents. And I'll say, it's just, when you talk about mortars and just admixtures alone, back in the day, you had a huge sand pile. You'd have mortar, you'd either use white or gray, you'd pop probably 2 bags, maybe 1, but 2 bags into the mixer. He would then add 15 shovelfuls of sand, 2¼ cubic feet. You gotta admit, if it's hot, he's on the job site all day, he's gonna have some strong hand or shovels of sand at the beginning, but by that end of the day, it is not gonna be the same. Then he adds in a pack of color, then he adds in, hopefully, the water repellent. And I have to say, 9 times out of 10, yes, but that 1 time out of 10, they don't do it. So it's just something that just makes, it's a better mousetrap, if you may. So joint profiles is another item that's super important. There's multiple different profiles that are on the market today, but honestly, the concave is the one we recommend. V is not bad, and I've seen some weathered, but unfortunately, when you talk about the rake joints, all it does is allow mortar to just sit on the ledge. Flush joint, by the way, is normally only done when it's going to be a stucco application. So the control joint should be, or not the control joint, the tooling of the mortar joint really should be the concave or the V. But I would say concave, and it actually is compressing that mortar. So thumbprint hard, you kind of ask, why is that saying thumbprint hard? It's just like it says. Once it's just pliable enough is when that they need to actually strike the joint. Here you can see if it striked a little too early, if the mortar was too wet, you get kind of a sandy look. But here's just an example of the tool that they use for the concave joint. So there's actually a tool for all of them, but concave is just the way to go in our book. So the water repellent admixtures in both block and mortar, it's just used together. It's a great system. Can't say enough. And then post-applied sealants, this is also a water repellent. So it's something that if you have single white construction for sure, highly, highly recommend that you have a post-applied, like sprayed. You can roll it or spray it, but really some of the water repellents really last quite a long time. So let me quickly see what kind of questions I have, and I may have to move on and answer at the very end. Info on the foam and CMU. Yep, I can get to you later. And then are there any measurements for the amount of water penetrative in a masonry wall per hour? There is. I cannot tell you what that is off the top of my head, but there's a Ryland test tube. And you basically have a test tube filled with water, and you're putting like a little a piece onto the wall of pliable material, and you're seeing how fast that moisture actually is sucked into the wall. So it's a Ryland test tube. And it's like the rate of so many milliliters or whatever the smallest amount of water per hour, but I just don't have that exact answer on that. On the water repellent, does not block filler and exterior paint give you the same? Yes. Painting is absolutely, that is your water repellent as well. So by far. All right, so let me move on just to finish up learning objective number 4. Specify a masonry solution that delivers superior moisture control and environmentally sound structure. So first and foremost, I know there's several different ways on specifications. You could do prescriptive, you can do performance. I have found that it's probably half and half in Florida anyways, when I call on the architects of what kind of method do they use for their specifications. But I'm trying not to choke. Using a performance method many times, of course, ComCheck would be one of the softwares that you could use. You might be able to design your wall a little less expensive. So it is something to certainly take a look at. Prescriptive, by the book, easy peasy, this is the way we do it. Nothing wrong with that. But sometimes using the performance method and being able to just give and take, you might have a system that you really are surprised about. So this chart is simply the table C402 showing that, for example, if you're in zone 2, you can design with continuous insulation under the group R with 7.6, or if your project maybe design-wise can't quite warrant that continuous insulation, you can actually design more or less with the reciprocal, which would be the U factor of less than 0.123. I know this chart is extremely difficult to see. So some of the compliance paths used, I mentioned prescriptive, performance. They actually have an ERI system as well, just depending on what kind of product that you have. What kind of project. And then lastly, thermal mass. What is thermal mass? That is something that I just want to make sure that the R value is important, but don't think of that as alone. Thermal mass is something that in a concrete product, if you design and it's the dead of winter, you're up north and it's freezing outside, that block is going to retain the heat for longer periods of time. So in the event, let's say you lose your electricity, you don't have to evacuate quite as early. The inverse for the summer months and our hurricanes that we have. If we lose our air, it's hot, we can stay inside safely for longer periods of time. So you think about the pets, children, the elderly. It's just very important to think about the thermal mass as well. This is just talking about the degradation. If water does go unchecked, you should always, always, always make sure if you've got a clean building and all of a sudden you're starting to see efflorescence, something else is evident, something else is going wrong. So you just need to make sure that you are checking and making sure that there are no signs of penetrations that you're not aware of. So honestly, by controlling moisture in masonry, your structure will always elect permanence and stability for years to come. So just to wrap up, very important to detail and execute flashing and weeps. They're really dead on a vital component for moisture mitigations, but it is a systems approach. Some of the block and mortar additives that are on the market today, they really give you a seamless solution. And again, if moisture does penetrate to the interior, it can cause structural degradation. It can have efflorescence. You can even go as far as certain health issues. So a good design that's executed properly, you will have a project, honestly, that will last a lifetime. So I'll just see if I have any other questions. Silicone water repellent, siloxane. There's another word too. It's not silicone, but siloxane is really the best when it comes to water repellents for both block and for mortar, especially for block. And the aggregate that's typically used in Florida is limestone. Limestone is what we mine. It does not affect the integral water repellent. It actually goes and they play very well, if you may. So, and then what is, oh, same one. And so limestone is the aggregate that's typically used in Florida, and it does not affect the integral water repellent. Most everything, the integral water repellent really is a product that plays very nicely with most other materials in your wall system. Personally, I have not known any issues because of that. The main thing is the integral will last the lifetime, but if you have an exposed single white project, I highly recommend that there is a post-applied water repellent as well. All right, I think that's it. Don't think I see any other questions.
All right. Thank you, Lisa.
Yes.
I think you covered everything. Looks really good. Oh, did this one just come in while we were
It
saying that?
did, but I'm not
Okay.
quite sure what I understand. As far as an equivalent to continuous insulation on a CMU, what option do we have? The option is to perhaps design using the U factor. So you have your the R value, that table, but the inverse is the U factor. So that could be a good, very good option. And I'm sure NCMA may not have the information as much on brick. Let me give you another website. It's called gobrick.com. It's put on by the Brick Institute of America. And it also has, I believe, 26 chapters, and it dives, deep dives. They have technical notes as well, and it will be an excellent website to show you some of the solutions that you need. So ncma.org is great for concrete. Gobrick.com is an excellent website for brick.
All right. So those of you, just as a quick reminder, all these presentations that you're seeing today and tomorrow actually are available in the resources. And I believe, Lisa, your contact information is on the beginning of this presentation. So if anybody has any additional questions,